Hello bachcho, welcome to JEENious classes. Today we are going to start with a new series called Relation and Function. Today is the first class of this series and today we are going to discuss about the Cartesian product of two sets and relation. If you are new to my channel, please do subscribe and press the bell icon so that you get notified about all the new videos I upload in this channel. Don't forget to like and share it with your friends and don't forget to comment me because your one comment inspires me to make a video of this kind next time. So let's start the class. So first of all, we are going to discuss about the Cartesian product of two sets, but before that, we must know what is an ordered pair. Ordered pair किसको बोलते हैं ये पहले हमको जानना है. देखो, मानो एक सेट है तुम्हारा पास A और उसमें बहुत सारा एलिमेंट्स है, लेट अस से A, B, C, D and all this. ओके, ऑर्डर्ड पेयर मतलब तुम कोई भी दो एलिमेंट इससे चूज करो. चूज एनी टू एलिमेंट्स फ्रॉम सेट A और उसको हम लोग लिखते हैं इन दिस वे एंड दिस इज व्हाट इज कॉल्ड योर ordered pair of set A. This is the ordered pair of set A. Clear? जिसमें ये A को हम लोग बोलते हैं the first coordinate. इसको हम लोग बोलते क्या है? The first coordinate. और इस B को हम लोग बोलते हैं second coordinate. This is called second coordinate. Is it clear? Is this much clear to all of you? मतलब ordered pair क्या है? कोई भी एक सेट तुम्हें दिया हुआ है, उनसे तुम दो एलिमेंट्स चूज करो and write it in this parenthesis. We call this pair as an ordered pair of set A. Is it clear? Okay, जिसका पहला वाला को हम लोग क्या बोलते हैं? फर्स्ट कोऑर्डिनेट और सेकंड को हम लोग क्या बोलते हैं? सेकंड कोऑर्डिनेट. राइट? यहां पर A is the first coordinate and B is the सेकेंड कोऑर्डिनेट. देखो बच्चों, दो चीज तुम्हें याद रखना पड़ेगा यहां पर. वो है ए बी. दिस ऑर्डर्ड पेयर इज नॉट इक्वल्स टू बी ए. दैट इज इफ द फर्स्ट कोऑर्डिनेट इज नॉट इक्वल्स टू द फर्स्ट कोऑर्डिनेट ऑफ द सेकेंड ऑर्डर्ड पेयर, वी कैन नॉट से टू ऑर्डर्ड पेयर्स आर इक्वल. मतलब 1 2, मन लगा के देखो, 1 2 और 2 1, ये जो दो ऑर्डर्ड पेयर है, दे आर नॉट इक्वल. ओके, अगर मानो कि दो ऑर्डर्ड पेयर इक्वल है, if two ordered pairs are equal, then guaranteed the first coordinate of the first ordered pair will be equals to the first coordinate of the second ordered pair. That is, यहाँ पर A will be equals to C. And the second coordinate of the first ordered pair will be equals to the second coordinate of the second ordered pair. मतलब यहां पर क्या होगा? B will be equals to D. Is it clear? So दो चीज याद रखो, A, B is not equals to B, A. This is number one. And number two, अगर दोनों ordered pair equal है, then their respective coordinates will be equal. Let us take an example. See this question. यहां पर बोला है फाइंड x एंड y where x plus 3, 7. बच्चों देखो यहां पर क्या दिया है? x plus 3, 7. That is the first coordinate is x plus 3 in the first ordered pair और second ordered pair के लिए first coordinate is 6. Therefore we must write that x plus 3, since these two ordered pairs are equals to 6. So from here we are getting x is 6 minus 3, that is 3. And number 2, 7 will be equals to 3x minus 2y. Therefore, if we replace x, we are going to have 7 equals to 9 minus 2y. That implies 2y equals to 2. मतलब क्या हुआ? y is equals to 1. मतलब यहां पर क्या आंसर होगा? Your x will be equals to 3 and y will be equals to 1. Is this clear to all of you? Have you understood what is ordered pair? Ordered pair किसको बोलते हैं? Of a particular set. Okay. Now let's move forward. which is called your Cartesian product of two sets. यहाँ पर we will discuss 5 most important points on Cartesian product of two sets. बच्चों Cartesian product of two sets किसको बोलते हैं? What is the definition of Cartesian product of two sets? मानो मेरा पास दो सेट है, एक है A, it is 1, 2 and 3, and there is another set, let us say B, which is your 4, 16 and 25. Let us say for an example. Okay? So A cross B किसको लिखते हैं? देखो, the definition of A cross B is, it is the set of the elements of ordered pair A comma B such that A belongs to A and B belongs to B. मतलब क्या हुआ? A cross B is the collection of all the ordered pairs जिसका first coordinate will come from set A and जिसका second coordinate will come from set B. Is it clear? मतलब यहां पर देखो बच्चों, A cross B क्या होगा? A cross B will give us 1, 4, 1, 16, 125, then 2, 4, then 2, 16, then 3, 25, then 3, 4, 3, 16, and 3, 25. Is this clear? So these are the elements of A cross B. हम लोग Cartesian product of two sets को A cross B बोलते हैं, right? So A cross B में क्या क्या आया? All the ordered pairs whose first coordinate is coming from set A and the second coordinate is coming from set B. Clear? Okay, so this is what is called your Cartesian product of two sets. बच्चों देखो अभी number of elements in A cross B. Number of elements in A cross B. बच्चों अच्छा से देखो, what is the cardinal number of? What is the cardinal number of set A? This is 3. What is the cardinal number of set B? This is again 3. Now you observe, what is the cardinal number of A cross B? देखो 1, 2, 3, 4, 5, 6, 7, 8, 9. मतलब cardinal number of A cross B is nothing but 9. Have you understood? मतलब हम क्या बोल रहे हैं? अगर cardinal number of set A is say m and cardinal number of set B is say n, then total number of elements in Cartesian product of two sets will be m into n. Is it clear? The cardinal number of A cross B will be what? The cardinal number of set A into cardinal number of set B. So इसको ऐसे याद रखो. Cardinal number of A cross B will be equals to cardinal number of set A into cardinal number of set B. This is the total number of elements present in A cross B. Is it clear to all of you? Absolutely clear. Okay. Now let's move forward. What is the diagrammatic representation of A cross B? Diagrammatically हम A cross B को कैसे रिप्रेजेंट करेंगे? इसको हम लोग बोलते हैं एरो डायग्राम. क्या बोलते हैं? एरो डायग्राम. वो चीज क्या है? देखो बड़ी सिंपल चीज है, कुछ नहीं. इसमें करोगे क्या? मेरा पास हम दो सेट हमने ड्रॉ किया, जो मेरा यहां पर दो सेट है A and B. This is my set A, this is my set B. और इसमें क्या है? 1, 2, 3. और इस सेट में क्या क्या एलिमेंट्स हैं? 4, 16 and 25. राइट? अच्छा अभी क्या कर रहे हैं? देखो यहां पर क्या था? 1, 4. मतलब हम क्या बोलेंगे? 1 is related to 4. How we pronounce this? 1 is related to 4. Okay? This 1, 4 का मतलब हुआ 1 is related to 4. Next, 1, 16 मतलब 1 is related to 16. 1 is related to 16. Similarly, 1 is related to 25 and all this. 2 is related to 4. 2 is related to 6. 2 is related to 25. 3 is related to 4. 3 is related to 6 and 3 is related to 25. 6 nahi, this is 16. Okay? Have you understood? So this is what is called your arrow diagram. Okay? This is how we diagrammatically represent A cross B. समझ में गया कि नहीं? Okay. The fourth point is how we represent graphical representation of A cross B. How we represent A cross B graphically. How we do that? It's pretty simple. We simply draw the coordinate axis and we plot those points on this plane. That is, in this case, it is 1, 4. So it will come somewhere like here. This point is 1, 4. And the other points also 1, 16. It will be somewhere here. It's 1, 16. And this thing goes on. इसका मतलब ये हुआ जितना भी ऑर्डर्ड पेयर्स हैं इसको इस प्लेन पे, जैसे हम लोग कोऑर्डिनेट ज्योमेट्री में किए हैं, इसको इस प्लेन पे तुम सिंपली प्लॉट कर दो एंड दिस इज व्हाट इज कॉल्ड योर ग्राफिकल रिप्रेजेंटेशन ऑफ ए क्रॉस बी. इसको हम लोग कभी कभी लैटिस डायग्राम भी बोलते हैं. ओके, नाउ लेट अस कम फॉर द फिफ्थ पॉइंट विच इज आवर प्रॉपर्टीज. तो ये प्रॉपर्टी हम लोग डिस्कस करेंगे. किसका प्रॉपर्टी? कार्टेशियन प्रोडक्ट ऑफ टू सेट्स का प्रॉपर्टीज. देखो बच्चों, नंबर 1, द फर्स्ट प्रॉपर्टी इज A cross B union C. This will be equals to A cross B union A cross C. This is the property. Number 2, A cross B intersection C. इसको हम लोग कैसे लिखेंगे? A cross B intersection A cross C. Number 3, A cross B minus C. इसका मतलब क्या होगा? A cross B minus A cross C. This is the third property. And the fourth property of Cartesian product of two sets is A cross B intersection C cross D. इसको हम लोग लिखते हैं A intersection C cross B intersection D. B intersection D. Let me just rub this. It will be what? B intersection D. Is it clear? So these are the four major properties of Cartesian product of two sets. We have to remember this. Okay? Proof is very simple. Proof you can try by yourself. Okay? I'm not doing proof over here. You can see any textbook, you can get the proof over there. Because proof is not needed, particularly for Cartesian product of two sets. Now let us start with this question. See this question. They have given A and B are two sets having 6 elements. Having 6 elements. A cross B has 6 elements. And if 3 elements are 1, 5, 2, 3 and 3, 5. इसका मतलब क्या हुआ? Your set A has the elements like 1, 2 and 3. And set B, it has the element 3 and 5. Is it clear? Now, what are the elements that you will have in A cross B? Look at very carefully. If A has 3 elements and B has 2 elements, then A cross B will have 6 elements. Because we know that the cardinal number of A cross B is cardinal number of A into cardinal number of B. So यहाँ पर cardinal number of A is 3, cardinal number of B is 2, therefore cardinal number of A cross B will be 6. Now, the 3 elements that are given over here are 1, 5, 2, 3 and 3, 5. Look at very carefully. Now, what will be the other elements? See, 1, 3, it is not there. So 1, 3 will come, this will come. Then 1, 5, that is there. 2, 3, that is there. 2, 5, it is not here. So 2, 5 will come here because we are calculating the Cartesian product of two sets. Then 3, 3, that is not there. So 3, 3 will again come in this set. So what are the 3 new elements that will be in A cross B other than the elements given over here? They are 1, 3, 2, 5 and 3, 3. That's it. Is it clear to all of you? Okay, let us move for the next part, which is our relation. So first of all, we have to understand what do you mean by a relation. That is the most important thing. What do you mean by a relation? A relation is basically a Cartesian product of two sets. It is basically a Cartesian product of two sets, but with a condition. But with a condition. जैसे मानो कि मेरा पास A is a set, let us say 1, 3, 5, and B is another set, let us say 1, 9, 16 and 36. Let us say. Now बच्चों देखो यहां पर रिलेशन क्या होगा. एक्चुअली आई टोल्ड यू दैट इट इज द कार्टेशियन प्रोडक्ट. कार्टेशियन प्रोडक्ट को हम लोग डेफिनेशन कैसे लिखते हैं? इट इज अ सेट ऑफ ordered pairs A, B such that A belongs to A and B belongs to B. Okay, this is the definition of Cartesian product. But what I told you, it is the Cartesian product with a condition. Now suppose if I impose a condition here, everything is same. Everything is same. But now I'm imposing a condition that your A square will be equals to B. This is a condition. Other conditions can also be there. This condition may vary. This will definitely vary. Okay. Now, this will be our relation. Why? Because a condition has been imposed here. A condition has been imposed here. Now you think, in that relation R, we denote relation by R. Now, in that relation set, what are the ordered pairs that will come where A square equals to B? It will be 1, 1, 3, 9, and nothing else. Because 5 square is 25 and 25 is not present in B. Therefore, our relation will have only the elements 1, 1 and 3, 9. That's it. Is it clear? That is why we always say that R means relation. The relation R is always a subset of A cross B. R is always a subset of A cross B. Okay. So we are clear about what do you mean by the relation. So relation is nothing but बच्चों क्या है? It is the Cartesian product with a condition. Right? Clear? Okay. Now let us come for the next part, which is called relation on a set. What do you mean by that? You see, यहां पर हमने सेट क्या क्या कंसीडर किए थे? एक किए थे A, एक किए थे B. One is A, another one is B. Now, if I define the relation on the set itself, that is what I want to say, your relation will be defined on set A itself. Like the relation R will be defined from A to A. Is it clear? From A. जैसे यहां पर कैसे किए थे? यहां पर रिलेशन मेरा कहां से कहां तक डिफाइन था? A to B. But in this case, when it is a relation on the set itself, it is the relation from that set to that set. That is, I'm talking about here A will be equals to 1, 3, 5, which is there. And your B in this case will be again A, which is 1, 3, 5. That's it. That's it. Nothing else. Right? Now, in this case, if I define the relation on the set itself, I say that A and B, it is the set of elements ordered pairs A, B, such that A belongs to A and B belongs to also A. But now I'm giving a condition that A square will be equals to B. In that case, this relation will contain only one element, that is 1, 1, because no other element chosen from set A whose square gives us a number which is very much within the set A. That is not there. Therefore, only 1, 1, this ordered pair will come in the set R. Have you understood this? So this is what we call relation defined on the set itself. Right? Let us see the third one, which is called number of relation possible. बच्चों बोलो A cross A में बड़ी सिंपल सा चीज है. बोलो A cross A में टोटल कितना एलिमेंट्स रहेगा? A cross A में कितना एलिमेंट्स है? 3. So what is the cardinal number of set A? 3. So what will be the number of elements in A cross A? It will be nothing but 3 square, that is 9. Yes or no? In Cartesian product of two sets, we are going to have 9 elements. Yes or no? But now the question comes, यहां पर जो 9 element है, let us just consider a general thing. Suppose your set A contains m elements and set B contains, let us say, n elements. तो बच्चों बोलो A cross B में कितना एलिमेंट्स आएगा? A cross B में टोटल नंबर ऑफ एलिमेंट्स कितना आएगा? mn एलिमेंट्स. ओके अभी ए क्रॉस बी में ए एम इंटू एन नंबर ऑफ एलिमेंट्स केम. अभी एक एक एलिमेंट तुम चूज करो. इट कैन ईदर पार्टिसिपेट इन द रिलेशन और नॉट. ईदर इट विल पार्टिसिपेट और इट विल नॉट पार्टिसिपेट. राइट. मतलब हर एक एलिमेंट के लिए मेरा पास दो ऑप्शन है. टोटल मेरा पास mn एलिमेंट्स है. एक एक एलिमेंट के लिए मेरा पास दो ऑप्शन है. Either it will participate in the relation or it will not participate in that relation. Therefore, total number of relations possible is 2 to the power mn. Is it clear? Therefore, number of relation possible for any set, if A is of elements m and B is of elements n, then total number of relation possible is 2 to the power mn. Is it clear? If it is defined on the set itself, mano A set, it has the cardinal number of A is say 3. Okay, let us take it general. Let us say the total number of elements is n. Then now if the relation is defined on the set itself, means we have to consider the Cartesian product A cross A. In A cross A, total number of elements will be nothing but n into n, which is nothing but n square. And the total number of relations possible in this case will be 2 to the power n square. Am I not correct? Have you understood this? Okay, fantastic. Now, let us move for the next one. It's domain and range. बच्चों देखो, यहां पर हम लोग मानो कि एक रिलेशन मेरा पास है. I am showing it in an arrow diagram. से यहां पर 1, 2, 3 है और यहां पर मेरा 4, 5, 6 है. Let us say. Now, let us say 1 is related to 5 and 2 is related to 4. That's it. Now, मेरा relation में क्या क्या ordered pair आ रहा है? मन लगा के देखो, क्या क्या ordered pair आ रहा है? 1,5 and 2,4. That's it. Is it clear? Now, for each of these ordered pair, you observe the first coordinate. You observe the first coordinate. The first coordinate here are 1 and 2. The first coordinate are 1 and 2, and that is your domain. So what is your domain? Your domain is 1, 2. Always the first coordinate which participate in the relation. Okay? Is it clear? See, whatever ordered pair are participating in the relation, the first coordinate, all the first coordinates will come in the set domain. And what about its range? The range is always the second coordinate of all the ordered pairs that has participated in the relation. Means here the range will be 5 and 4. Is this clear? So is the conception of domain and range clear to all of you? Absolutely. Okay. Let us move for the next one. It's inverse of a relation. See बच्चों, यहां पर मेरा relation क्या आया? My relation is 1,5 and 2,4. Right? Now, what is the inverse relation? मन लगा के सुनो बच्चों, what is the inverse relation? अच्छा, हम लोग पहले set builder form में लिखते हैं. Inverse relation क्या है? Your inverse relation is a set of elements B, A such that A, B belongs to R. अगर A, B R में है, then B, A will lie in R inverse. Is it clear? जैसे यहां पर मेरा R में क्या क्या है? 1,5 and 2,4. Therefore, your inverse of this relation will be 5,1, 4,2. That's it. मतलब क्या हुआ बोलो तो बच्चों? R में जिसका डोमेन था, R में जो डोमेन था, वो अभी क्या हो गया? R इनवर्स में क्या हो गया? वो रेंज हो गया. देखो यहां पर मेरा डोमेन क्या था? 1 and 2. अभी R इनवर्स में मेरा रेंज क्या हो गया? रेंज हो गया 1 and 2. मतलब R में जो डोमेन था, R इनवर्स में वो रेंज हो गया, और R में जो रेंज था वो R इनवर्स में डोमेन हो गया. इज इट नॉट सो? देखो R में तुम्हारा रेंज क्या था? 5 and 4. नाउ लुक इट केयरफुली. R इनवर्स में तुम्हारा डोमेन क्या है? डोमेन इज 5,4. दैट्स इट. मतलब क्या सीखा? R में जो एलिमेंट्स है उसका अगर ऑपोजिट ऑर्डर्ड पेयर कर दोगे, मतलब 1,2 अगर R में है, देन 2,1 विल बिलोंग टू R इनवर्स. क्लियर एकदम. और एक चीज याद रखो, R का जो डोमेन है R इनवर्स का वो रेंज होगा और R का जो रेंज है R इनवर्स में वो डोमेन होगा. Absolutely. Is it clear now? Okay. Now let us come for the next one, which is your types of relation. This is the most important thing. What are the types of relation that we can have? Okay, let us check. So types of relation क्या होगा देखो. First of all is what called your empty relation. Empty relation किसको बोलते हैं? मान लो मेरा पास एक रिलेशन है जिसमें कोई भी एलिमेंट्स नहीं है. Is it possible? Let us check. Let us say A is a set of elements, say 2, 3, 4. And B is another element, let us say 16, 25, 36. Correct? Okay, बच्चों, अभी देखो, अगर हम एक रिलेशन यहां पर डिफाइन करें कि these are the sets of ordered pairs A, B such that A belongs to A and B belongs to B, और जो कंडीशन दिया हुआ है वो ऐसा है कि A क्यूब इज इक्वल्स टू B. A क्यूब इक्वल्स टू B. अभी बच्चों बोलो यहां पर R में क्या क्या आएगा? A क्यूब विल बी इक्वल्स टू B. अच्छा, 2 क्यूब कितना होता है? 8. B में नहीं है. 3 क्यूब कितना होता है? 27. सेट B में वो नहीं है. 4 क्यूब कितना होता है? 64, जो भी मेरा B में नहीं है. मतलब यहां पर जो R होगा उसमें कोई एलिमेंट आएगा? नहीं आएगा. मतलब क्या हुआ? R इज एन एम्प्टी सेट. R इज एन एम्प्टी सेट. इसको ही हम लोग बोलते हैं एम्प्टी रिलेशन. मतलब एम्प्टी रिलेशन क्या है? एम्प्टी रिलेशन इज अ रिलेशन वेयर देयर इज नो एलिमेंट प्रेजेंट इन दैट रिलेशन. इज इट क्लियर? ओके. Now let us come for universal relation. Universal relation क्या है? Okay, एक काम करते हैं. मानो मेरा सेट A is, मानो सेट A is say we are having brother 1 and brother 2, और सेट B में जो है वो है मेरा sister 1 and sister 2. अभी हमने क्या किया? एक चीज देखो, अगर हम तुम्हें बोले कि यहां पर A क्रॉस B निकालो, तुम क्या बोलोगे? You will say, sir, it will be B1S1, B1S2, B2S1, and B2S2, correct? So these are the 4 elements that are coming in A cross B. Now, if I define a relation which consists of the ordered pairs A, B such that A belongs to A and B belongs to B, but here what I'm saying is A is brother of B. A is brother of B. Now think about it. B1 is the brother of S1 as well as B1 is the brother of S2. Similarly, B2 is the brother of S1 as well as B2 is the brother of S2. मतलब क्या हुआ? यहां पर R में भी ये सब एलिमेंट्स आ जाएगा. ये सब एलिमेंट्स यहां पर आ जाएगा. करेक्ट? बिकॉज दे आर ऑल रिलेटेड टू these numbers. Okay, these ordered pairs. Now we have seen that here the relation is coming to A cross B. When you find that your relation is same as your A cross B, we say that this relation is universal relation. Is it clear to all of you? Okay. Now let us come for the next one, which is called reflexive relation. What is reflexive relation? देखो बच्चों, reflexive relation is अगर मानो एक सेट है तुम्हारा 1, 2 and 3. Okay? Now a relation is defined on this set A. इसका मतलब सेट मतलब रिलेशन R में अगर all the elements are present in their pairs, all the elements present in their pairs, other element whether it exists or not, it doesn't matter to me. It doesn't matter to me whether other ordered pairs are there or not. It doesn't matter to me. But if you find that for all elements that belongs to A, its ordered pairs always belongs to the relation, then we call that relation a reflexive relation. reflexive relation. Is this much clear to all of you? अगर कोई भी एक सेट में जितना भी एलिमेंट्स है उसका पेयर्स, खुद का जो पेयर है, मतलब जैसे 1 है, 1 का खुद का सब पेयर क्या होगा? 1,1. सो वो ईच एंड एवरी पेयर, नॉट ओनली कि एक पेयर है या 2 पेयर है, जितना भी एलिमेंट्स ए में है सबका पेयर विथ इटसेल्फ is present in your relation R, then we call that relation a reflexive relation. Whether other ordered pairs are there or not, it doesn't matter to me. But if all the pairs with the number itself, with the element itself is present there, all the ordered pairs, then we call that relation a reflexive relation. Is this clear to you? Okay, let us do one thing. Let me just take a set which has, let A be a set which has, let us say, A1, A2, A3, and so on. Let us say there are n elements in that set. There are n elements in that set. Now, a relation is defined on that set. A relation is defined on that set. Okay. Now, my question is this. How many number of reflexive relation possible? How many number of reflexive relation possible? What is the question? Let us just write it here. How many reflexive relation possible? जहां पर A set consist of n elements. अच्छा बच्चों एक चीज बोलो, A क्रॉस A में कितना नंबर ऑफ एलिमेंट्स रहेगा? A में अगर n एलिमेंट्स है तो A क्रॉस A में कितना रहेगा? n स्क्वायर. Okay, let us do one thing. Let me just write all those elements in row and column wise. I have written this one A1, A2, A3 row wise, and यहां पर हम लोग लिखा है column wise. Okay. Now if I plot all the elements will look like this. This is A1, this is A1, A2, A1, A3, and all the n square element are written here. Now, this one is what called your diagonal elements. These are the diagonal elements. A1, A1, A2, A2, A3, A3. These are all diagonal elements. And the non-diagonal elements are divided into 2 parts. One is the upper half, the other one is the lower half. The upper half is what called your upper triangular non-diagonal elements. And नीचे वाला जो है वो है, it is non-diagonal lower triangle. Non-diagonal elements in the lower triangle. So what I have done, I have divided all those elements in 2 bigger groups. One is your diagonal elements and another one is your non-diagonal elements. और non-diagonal elements को हम लोग क्या किया? 2 पार्ट में डिवाइड किया. एक है upper triangle, एक है lower triangle. Is it clear? Now my question is, how many number of reflexive relations are possible? देखो बच्चों, पहले reflexive relation मतलब क्या हुआ कि यहां पर जितना भी diagonal elements है सबको आना पड़ेगा. मतलब A1, A1, this ordered pair, A2, A2, A3, A3, An, everything will come in that set if it is a reflexive one. Now the second question is, whether the non-diagonal elements are present or not, it doesn't matter to me. It will be a reflexive relation because all the diagonal elements, that is the pair elements with itself, is present in my relation. Is it clear? अच्छा, तब अभी बोलो कितना नंबर ऑफ, पहले है टोटल नंबर ऑफ कितना एलिमेंट्स है? वी आर हैविंग n स्क्वायर एलिमेंट्स, राइट? टोटल एलिमेंट्स कितना है? n स्क्वायर. ओके, इसमें नॉन डायगोनल एलिमेंट्स कितना है बच्चों, बोल सकते हो? यहां पर बोलो डायगोनल एलिमेंट्स कितना है? n. मतलब नॉन डायगोनल n इज डायगोनल एलिमेंट्स, नंबर ऑफ डायगोनल एलिमेंट्स. ओके, नाउ व्हाट इज नॉन डायगोनल एलिमेंट्स? How many number of non-diagonal elements are there? It is nothing but n square minus n. Yes or no? It is n square minus n. That is the total number of non-diagonal elements. अच्छा बच्चों देखो, यहां पर क्या बोला था हम कि यहां पर कोई भी एलिमेंट आ भी सकता है, नहीं भी आ सकता है. It doesn't matter to me. So we are having n square minus n number of non-diagonal elements, and each element can come in the relation or it may not come. So we are having 2 options for all the non-diagonal elements. So how many number of ways are there of selecting non-diagonal elements? It will be 2 to the power n square minus n. Am I correct? So this is the total number of reflexive relation that is possible, because selecting all the diagonal elements, there is only one way. And other non-diagonal elements, they can come or may not come. So the total number of ways is 2 to the power n square minus n. It implies total number of reflexive relation possible is 2 to the power n square minus n. Is it clear to all of you? Absolutely. Okay. Please do remember the total number of total number of reflexive relation possible in a given set. It is very, very important for your entrance point of view. Okay, now let us come for the next one, which is called your identity relation. Now, very interesting, very closely related with reflexive relation. In reflexive relation, what I told you, that every element of set A must come with its pair. In identity relation also, the same rule applied. That is, all the elements of set A with its pair, it must come in the relation. But, in identity relation, there should not be any non-diagonals element present. Is it clear? मतलब हम क्या बोल रहे हैं, अगर मानो कि एक मेरा सेट है A जिसमें एलिमेंट है 1 2 3, सो आइडेंटिटी एलिमेंट हम लोग इसको ऐसे लिखते हैं. सो आइडेंटिटी एलिमेंट विल बी व्हाट? 1 1 2 2 and 3 3. That's it. No more elements should come in identity relation. Is it clear? मतलब क्या हुआ देखो, all identity elements, all identity relation is a reflexive relation, but all reflexive relation may not be an identity relation. Is it clear to all of you? Okay. Now let us move for the next one, which is your symmetric relation. What is symmetric relation? Symmetric relation states that if A, B belongs to R, अगर A, B belongs to R है, इसका मतलब guaranteed B, A must belongs to R. Then you will say that relation is a symmetric relation, otherwise not. What is a symmetric relation? अगर A B है, मतलब मान लो कि मेरा एक सेट है 1 2 3 और मेरा एक रिलेशन में एक एलिमेंट आया है से 1 and 2. अगर 1 2 प्रेजेंट है इन R, then 2 1 must present in R. तभी वो रिलेशन जाके क्या होगा? Symmetric relation होगा. Is it clear to all of you? Okay. Now let me say how many number of symmetric relation possible. So let me just recall that array again. Here there are total number of elements are n square in A cross B. यहां पर होगा A cross A because the set is defined on the set itself. So total number of elements is n square. अच्छा, total number of diagonal elements कितना है? n. मतलब total number of non-diagonal elements क्या है? n square minus n. Is it clear? n square minus n is the total number of non-diagonal elements. अभी मेरा जो गोल है टू फाइंड आउट हाउ मेनी नंबर ऑफ सिमेट्रिक रिलेशन पॉसिबल. हाउ मेनी नंबर ऑफ सिमेट्रिक रिलेशन पॉसिबल. ओके बच्चों, एक चीज तुम लोग देखो, यहां पर टोटल नंबर ऑफ नॉन डायगोनल एलिमेंट्स इज n स्क्वायर माइनस n. मतलब अपर हाफ या अपर ट्रायंगल या लोअर ट्रायंगल में टोटल नंबर ऑफ एलिमेंट्स कितना है? It will be n square minus n divided by 2. This is the total number of elements in either in the upper triangle non-diagonal elements or in the lower triangle non-diagonal elements. Correct? Okay. अगर मानो कोई भी एक एलिमेंट तुम चूज किए हो, कोई भी एक एलिमेंट तुम नॉन डायगोनल एलिमेंट से चूज कर रहे हो, मतलब क्या? मानो A4, A1 I have chosen. इसका मतलब A1, A4 has to be taken in my relation, otherwise it will be not a symmetric one. मतलब यहां पर जो n स्क्वायर माइनस n बाई 2 एलिमेंट्स है, दैट इज द नॉन डायगोनल एलिमेंट्स ईदर इन द लोअर ट्रायंगल और इन द अपर ट्रायंगल. कोई भी अगर एक तुम एलिमेंट चूज करोगे, उसका कॉरस्पॉन्डिंग एलिमेंट, इफ यू चूज द लोअर ट्रायंगल, देन उसका कॉरस्पॉन्डिंग एलिमेंट इन द अपर ट्रायंगल यू हैव टू चूज. देन ओनली इट विल बिकम अ सिमेट्रिक रिलेशन। मतलब टोटल नंबर ऑफ सिमेट्रिक रिलेशन कितना होगा बोलो बच्चों? यहां पर होगा 2 to the power n स्क्वायर माइनस n बाई 2। क्यों 2 to the power? क्या? क्योंकि हम लोग मान लेते हैं कि लोअर ट्रायंगल हमने कंसीडर किया है, तो लोअर ट्रायंगल में मेरा कितने एलिमेंट्स है? n स्क्वायर माइनस n बाई 2। अभी एक एक एलिमेंट के लिए तुम्हारे पास दो ऑप्शन है। एक ऑप्शन है इधर यू कैन टेक इट और यू विल नॉट टेक इट। So if you take it, you have to take the corresponding elements in the upper triangle also. मतलब total number of reflexive relation for the non-diagonal elements will be 2 to the power n square minus n divided by 2. Is it clear? अभी देखो बच्चों, symmetric relation में अगर diagonal elements आ जाए तो कोई दिक्कत नहीं, कोई प्रॉब्लम नहीं। I can take it. Why? लॉजिकली सोचने का कोशिश करो। अगर मानो a1, a1 है, मेरा सिमेट्रिक रिलेशन का डेफिनेशन क्या है? अगर ए बी आर में है देन बी ए भी आर में होगा, राइट? तो यहां पर a1 अगर आर में है, इसका मतलब a1 आर में है। इज इट क्लियर? मतलब diagonal elements, if diagonal elements are present there, it has no problem. Even if it is not present, then also it has no problem. Is it clear? So diagonal elements मेरा कितना है? n number of diagonal elements are there. So for एक एक एलिमेंट के लिए तुम्हारे पास चॉइस कितना है? दो चॉइस। Either you will take it or you will not take it. So if you take it, there is no problem. If you don't take it, then also there is no problem. It will become a symmetric relation, right? Because already we have considered for the non-diagonal elements thing. So टोटल नंबर ऑफ एलिमेंट्स मेरा है n डायगोनल एलिमेंट्स। मतलब एक एक के लिए मेरा ऑप्शन कितना है? दो। सो इट विल बी 2 to the power n. Is it clear? So total number of symmetric relation possible is 2 to the power n square minus n by 2 into 2 to the power n. That gives us 2 to the power. That means 2 to the power n square plus n by 2. This is very, very important. Total number of symmetric relation possible is 2 to the power n square plus n divided by 2. Is it clear to all of you? Okay, let us move for the next one. The next one is called anti-symmetric relation. Symmetric relation क्या बोला? अगर AB है, अगर AB R में है, then क्या बोला? BA को भी R में होना है, तभी जाके वो सिमेट्रिक होगा। लेकिन एंटी सिमेट्रिक बोल रहा है अगर A, B R में है, that implies B, A should not belongs to R. Is it clear? एंटीसिमेट्रिक रिलेशन किसको बोला? अगर AB रिलेशन में है तब BA कभी भी उस रिलेशन में नहीं आएगा, तभी जाके वो होगा एंटीसिमेट्रिक रिलेशन। इज इट क्लियर? अच्छा एक चीज देखो, अगर मान लो 1, 2 इज इन R, इट मीन्स व्हाट? 2, 1 शुड नॉट बिलोंग्स टू R। मतलब नॉन डायगोनल एलिमेंट्स में सोचो ऐसे कि अगर लोअर ट्रायंगल का कोई भी एलिमेंट हम लेंगे, उसका कॉरस्पॉन्डिंग जो एलिमेंट अपर ट्रायंगल में है वो हम लोग नहीं लेंगे। इज इट क्लियर टू ऑल ऑफ यू? ओके, तो नॉन डायगोनल एलिमेंट्स तो क्लियर हो गया। अभी आते हैं डायगोनल एलिमेंट्स। डायगोनल एलिमेंट्स क्या एंटीसिमेट्रिक रिलेशन में आ सकते हैं? लेट अस चेक। एंटीसिमेट्रिक बोल रहा है और इसका जो माने रिवर्स जो डेफिनेशन है वो बोल सकते हैं हम लोग। अगर ए बी आर में है एंड बी ए आर में है, दैट इंप्लाइज ए शुड बी इक्वल्स टू बी। दिस इज द डेफिनेशन ऑफ एंटीसिमेट्रिक। और इसका जो रिवर्स है वही हमने यहां पर बोला कि अगर ए बी आर में है तब बी ए आर में कभी नहीं होगा। समझने का कोशिश करो, ये थोड़ा सा कंफ्यूजिंग है। अगर ए बी आर में है, बी ए आर में है, तब इट इज ओनली पॉसिबल इफ इट इज एंटीसिमेट्रिक, ए और बी दोनों को इक्वल होना पड़ेगा। इसका मतलब इज इट नॉट टॉकिंग अबाउट द डायगोनल एलिमेंट्स? थिंक अबाउट इट। डायगोनल एलिमेंट्स में मानो 1, 1 है। अगर 1, 1 है, इसका मतलब 1, 1 है। गेटिंग माई पॉइंट? 1, 1 है मतलब ए बी अगर आर में है देन बी ए भी आर में है। भी R में है, बिकॉज 1,1 अगर R में है, उसको उल्टाओगे तो क्या होगा, उसको रिवर्स करोगे तो क्या होगा, 1,1 दैट बिलोंग्स टू R. इसका मतलब देखो यहां पर A इज इक्वल्स टू B हुआ, मतलब 1 इक्वल्स टू 1 इन दिस केस. मतलब what I want to say is that if you choose the diagonal elements in anti-symmetric relation, there is no problem. We can choose the diagonal elements here. But if A comma B belongs to R, then B comma A should not belongs to R. That you have to remember for anti-symmetric relation. Is it clear? Okay. चलो एक काम करते हैं. How many number of anti-symmetric relation are possible? Let us check. Let me just recall array. This is this. बच्चों देखो एंटी-सिमेट्रिक रिलेशन क्या होगा. एक चीज तुम लोग समझ लो कि अगर मानो A1 A2 और यहां पर हम लोग ले रहे हैं A2 A1. ओके, नाउ पॉसिबिलिटी क्या हो सकता है कि A1 A2 मेरा रिलेशन में है, तब A2 A1 क्या होगा, ये रिलेशन में नहीं होगा. मानो A1 A2 नहीं है, A2 A1 है, चलेगा, ये भी एंटीसिमेट्रिक है. दोनों ही नहीं है तब भी एंटीसिमेट्रिक है. लेकिन दोनों है ये कभी एंटीसिमेट्रिक हो नहीं सकता, बिकॉज A कॉमा B अगर है देन B कॉमा A भी है, ये तुम्हारा एंटीसिमेट्रिक रिलेशन में नहीं आएगा. इसके लिए बोला A1 A2 इसमें है, then A2 A1 should not belongs to the relation. Then only we will say that they are anti-symmetric relation. Is it clear to all of you? अच्छा, यहां पर बच्चों एक कंफ्यूजन आ सकता है कि अगर दोनों में ही नहीं है तब ये केस हम लोग क्यों कंसीडर कर रहे हैं. दोनों में ही नहीं है मतलब क्या, डेफिनेशन ही तो काम में नहीं आ रहा है. क्योंकि डेफिनेशन क्या है, अगर A कॉमा B है एंड B कॉमा A है, देन A विल बी इक्वल्स टू B. अगर A कॉमा B नहीं है तो B कॉमा A भी नहीं रहेगा. सो बाय डिफॉल्ट दोनों नहीं है, दोनों चीज नहीं है. दैट ऑल्सो कम्स इन आवर एंटी-सिमेट्रिक रिलेशन. इज इट क्लियर? अच्छा बच्चों, अभी हम लोगों का मेन चीज जो आता है वो है कितना नंबर ऑफ एंटी-सिमेट्रिक रिलेशन पॉसिबल. कैन यू फाइंड इट आउट? लेट अस चेक. देखो एंटी-सिमेट्रिक रिलेशन के लिए क्या हो रहा है, हर एक एलिमेंट के लिए मेरा पास 3 चॉइसेस हो रहे हैं. सोच के देखो, हम क्या बोला अभी A1 A2 और A2 A1 हम लोग पेयर में ले रहे हैं. अगर A1 A2 है, A2 A1 होना नहीं चाहिए. अगर A1 A2 नहीं है तब A2 A1 होगा. अगर दोनों ही नहीं है तब भी एंटीसिमेट्रिक होगा, लेकिन दोनों एक साथ हो नहीं सकता, राइट? So for every element, again I'm taking in pairs, so I'm simply considering the lower triangle. It means by default you are choosing the upper triangular non-diagonal elements also, because I'm taking here as a pair. So अभी क्या होगा देखो बच्चों, यहां पर हर एक एलिमेंट्स लोअर ट्रायंगल में, या तुम अपर ट्रायंगल लो, कोई भी लो, चॉइस इज योर्स. तो हर एक एलिमेंट के लिए मेरा पास कितना चॉइसेस हो रहा है, 3 choices, right? So how many number of non-diagonal elements in the lower triangle there are? There are n square minus n divided by 2. This is the total number of elements, non-diagonal elements in the lower triangle. हर एक एलिमेंट के लिए मेरा पास 3 choices है. So it will be 3 to the power n square minus n divided by 2. Yes or no? These are the 4 non-diagonal elements. Now, what about the diagonal elements? Now, diagonal elements, they can come, they may not come. Still, it will be an anti-symmetric relation. Okay? Diagonal elements में मेरा कितना diagonal elements है? n diagonal elements है. एक एलिमेंट के लिए मेरा कितना choices है? 2 choices. Either I will take it or I will not take it. So there are n diagonal elements and choices are 2. Therefore, the total number of anti-symmetric relation that can be formed is 3 to the power n square minus n by 2 into 2 to the power n. These are for the diagonal elements and these are for the non-diagonal elements. Is it clear? Is this clear? So therefore, the total number of anti-symmetric relation will be 2 to the power n into 3 to the power n square minus n by 2. Is it clear to all of you? Absolutely. Okay. Now let us move forward. Let us move forward. The next two things which are, first is transitive relation. What is transitive relation? Transitive relation states that if A, B belongs to R and B, C belongs to R. Remember it very carefully. A, B and B, C. Can you find out a similar thing here? Here it is B. Here also it is B. If it is so, like if I say 1, 2 is present in R and 2, 3 belongs to R. If it is so, and if you want to make it transitive, all you have to do is A, C, it has to belongs to R. A, C must belongs to R if it is a transitive relation. मतलब यहां पर क्या होगा? अगर 1, 2 R में है, 2, 3 R में है, then 1, 3 must belongs to R. That is the definition of transitive relation. Is it clear? और अगर मानो एक फंक्शन, एक रिलेशन जो मेरा रिफ्लेक्सिव भी है, सिमेट्रिक भी है, as well as it is transitive, then we call that relation an equivalence relation. Is it clear? So equivalence relation क्या है? कोई भी relation जो reflexive है, symmetric है, as well as it is transitive. Is it clear to all of you? Absolutely. Okay, so let us just close our class here. Hope you have enjoyed the class. If you have really liked my class, don't forget to hit the like button and share it with your friends. And don't forget to comment me whether you have not understood any part of this class. Please comment me in the comment section so that I can answer your problem in my next class. And those who are new to my channel, please do subscribe and press the bell icon so that you get notified about all the new videos I upload in this channel. We are having our learning app in Google Play Store. Link has been given in the description box. So you can download the app from there. There I used to come twice a week live. There you can ask me all your doubts and questions regarding mathematics in the app itself. And it's all free. So keep learning, keep watching, and stay tuned to us. Thank you. Goodbye.